Okay, here. Let's talk about implicit differentiation, okay? So, well, like, I know like this is the one of the most like, difficult part for like this course, okay? Because like you do not understand well about like differential equation. I mean, implicit differential equation, okay? But like, I can tell you this is not something new. That's exactly the same with chain rule, okay? That's why when I talk about like chain rule before, I said chain rule is most important part of this course, okay? This is reason why, okay? So let me try to explain this, okay? But do you remember the independent variable and dependent variable? Basically, like we say in general, okay? X as independent variable and Y as dependent variable, okay? So which means Y is a function of X. Does it make sense? Okay? So let me give you one silly example, then you can easily understand this, okay? Here we go. So for example, it's really easy, okay? Here we go. It is perfect position here. Then if I say I have function which is, give me 1 second. Oh, here we go. X squared plus 1 to the 4. Okay? Just two-layer chain of problem, right? Then if I take the derivative of this guy, as we practice a lot, and we can do this, right? Outside function prime 4 cubed, right? And then inside function. And then once you write this one, you have to multiply inside function prime, which is chain, right? Does it make sense? But let me try to change the name, okay? If I say my function, inside function, x squared plus 1 as y, then what happened? Here we go. Let's say inside function as y, okay? Then let me just rewrite this guy with y, okay? Instead of like square plus 1, okay? Then this part will be written by y to the 4 prime, right? Y to the 4 prime equal to 4 times, this part is y, right? Then let me try to write y instead of x squared plus 3, plus 1, y cubed, and this guy came from this guy, which is y prime. Does it make sense? Okay? So, well, look at that. I just rewrite my chain rule thing in terms of y. Is it okay? But look at that. If you compare with this, okay, look at this guy. We know x to the 4 prime is equal to simply 4x cubed, right? But from this argument, and I said y to the 4 prime is equal to 4y cubed. I really want to stop here, but we are not done yet. We have to multiply y prime as well, okay? Do you know what is different between these two? That's easy. Since x is independent variable, so there is no inside. So that's why, x to the 4 prime is just simply 4x cubed, okay? But since y is dependent variable, okay? As I told you, y itself is a function of x, okay? So which means there is hidden part inside of y, okay? So y to the 4 prime, which has 2 layers, okay? Power 4 is outside, and the y itself is inside function. Then you have to do the chain rule, okay? But do you think I'm doing like something like implicit differentiation thing? Well, I'm just talking about chain rule, right? But you know what? This is implicit differentiation, okay? So basically, like, all the explicit function can be written in terms of implicit. So which means like, it is not y equal to something, but like, they could be like variable x and y could be combined. Then just like you can take the derivative with like that, which means you don't have to change as explicit form. Does it make sense? Okay? Now let's practice, okay? As I told you, implicit differentiation is not something new, but it is exactly the same with the chain, okay? But keep that in mind. Y is not independent variable, but it is dependent variable, which means it is a function of x, okay? So from this point, since we are not going to change as explicit form, so we're going to use this notation, okay? We will take the derivative with respect to x, okay? Whenever I write d over dx means we will take the derivative with respect to x, okay? Then look at the first one. X squared prime, it is definitely just 2x, right? Then what about second function, y squared? Keep that in mind. There's two layers, okay? So y squared prime is simply 2y, but don't forget you have to multiply dy over dx, or y prime, doesn't matter, okay? Doesn't matter, okay? And that's it. We're done the left-hand side. What about right-hand side? 4 prime, oh, come on. Constant prime is numerical 0, okay? Now, we have to solve for dy over dx, okay? Let me subtract 2x on both sides. Then this guy can be written by 2y times dy dx is equal to negative 2x, okay? Divide by 2y on both sides. Then your dy dx is equal to negative 2x over 2y, which is negative x over y. Is that okay? Then what about problem B? We will do same thing, okay? But you have to be careful for the second one. I will tell you later, okay? Here we go. We're going to take the derivative with respect to x, okay? Then first term, 2y squared prime is 4y, but don't forget you have to multiply dy over dx or y prime, okay? But look at second term. I'm talking about this guy. Troublesome, x times y. X times y. There's no shortcut, but you have to do the product rule, right? So I'm talking about two parts. Here we go. Let's say x is first function and y is second function. Is that okay? And you have to do the, like, no matter what, you have to do the product, okay? Here we go. So plus, by the product rule. First one, x prime is 1. That's it, right? Times second function, just y. And plus, because it is product form. And then first function, x times second function y prime, which is y prime, okay? Or dy dx, okay? So what I want to say is this part. Was product rule, right? And that's within the left-hand side, okay? Now let me move to the right-hand side, okay? Equal to x squared prime is 2x, and constant 3 prime equal to 0. That's it, okay? So now we have to clean up this guy, okay? We will solve for dy over dx, which means we're going to do the moving, okay? Everything concerned with dy dx, includes dy dx, will be left on your left-hand side. Otherwise, move to right-hand side, okay? Look at left-hand side. This guy, y, doesn't have dy dx, right? This will be moved to the right-hand side. So here we go. Then, okay, let me write here, okay? On the left-hand side, you have 4y dy dx. And then we have x dy dx is equal to 2x, and this y came from left-hand side, okay? And on your left-hand side, let me pull out dy dx, okay? Then this is, with big parentheses, dy dx. Inside the remaining part, okay? 4y plus x equal to 2x minus y. Now let's divide whole this thing by on both sides, okay? Then your answer, dy over dx is equal to 2x minus y, which was on your right-hand side, over 4y plus x, which came from left-hand side, okay? This is the answer, and this is implicit differentiation, okay? Let me give you a couple more examples, okay? But keep that in mind. Even I give you like just a couple problems in this lecture, but you have to practice as much as possible, okay? From here, web assign, your instructor's lecture note, textbook, okay? And practice as much as possible, okay? You have to be good at like this kind of skills, okay? So here we go. Implicit differentiation, okay? We're gonna take the derivative with respect to x, okay? Then what happened? Look at your left-hand side. Oh, you have to realize it is product form. E to the y is first function, and sine x is your second function, okay? Let's do the product rule a little quick, okay? Here we go. First term prime, e to the y prime is e to dy because it's exponential function with base e, right? But don't forget you have to multiply dx dy over dx because y is the represented inside function, okay? Times sine x. Don't forget we are doing the product, okay? And plus first function times second function prime. Sine x prime is cosine x, okay? So again, let me emphasize one more time, okay? This whole part came from product, right? And then is equal to. Now let me move to the right hand side, okay? X prime, since it is independent variable, you don't have to worry about it, just what, that's it, okay? But what about second part? Oh, x times y, which is another product form, okay? So here we go. So let's say, let me use like this color for first function, x, and y is second function. Is that clear? Then do the product, okay? There's no shortcut, okay? You have to do it, okay? X prime is 1 times second function plus first function, original one, times second prime. Y prime is y prime, which is dy dx, right? That's it. Now we're ready, okay? Now we have to clean up this one with dy over dx, okay? It's big moving, okay? Everything includes dy dx will be moved to the left hand side, otherwise right hand side, okay? Here we go. So let me do on this side. Okay? So first of all, the first term, e to the y times sine x. Let me change the order. What's left hand side and leave on the left hand side, okay? And then from the right hand side, this guy came from right hand side, okay? And what are right hand side? 1 and y. Then e to the y times cosine x must be here, minus e to the y cosine x. Are you with me so far? Then on the left hand side, let me pull out your common factor, which is dy dx, okay? Then this can be written by with big parentheses, common factor. And here, e to the y times sine x minus x equal to 1 plus y minus e to the y times cosine x. Is that clear so far? Then we're going to divide by like this one on both sides, okay? Then your dy dx is equal to 1 plus y minus e to the y times cosine x over e to the y sine x minus x. That's it. Okay? So what about d? Here we go. Let me take the derivative with respect to x, okay? Look at left hand side. It is chain, right? Cubed is outside function, and you have x squared plus y squared as the inside function, okay? So it will be, let me use different color, okay? 3 squared, which is outside function, right? Then let me write your inside function, which is x squared plus y squared. Once you write the inside function, you have to multiply second layer prime. X squared prime is 2x, and y squared prime is plus 2y. And don't forget dy over dx as the channel or implicit differentiation, okay? That's it, okay? With the left hand side. What about right hand side? 2y to the 4 prime is 8 y cubed. Then you have to multiply dy dx as a channel or implicit differentiation, okay? And the last one, 6x squared prime is just simply 12x. That's it, okay? Now, as we did in the previous problem, we have to solve for dy over dx. How can you do it? So it is important skill. Okay, look at this one very carefully. Okay, here we go. So what we're gonna do is look at that. On the left hand side, like we have one without dy dx and one with dy dx in the one parenthesis. Okay. So what I'm gonna do is I'm gonna do the big distribution. Okay. I'm talking about whole this thing will be distributed inside of like this parentheses, okay? This is really important skill, okay? And just try to follow me, okay? Here we go. Then what happened? 3 times 2, 6x times x squared plus y squared square, right? That's it, okay? The second term, plus 6y and x squared plus y squared square with dy dx, okay? Then we can totally separate your dy dx term and without dy dx term on the left hand side, okay? And right hand side, just rewrite one more time. Then we're gonna do the moving, okay? 8y cubed dy dx plus 12x, okay? Now, let me move like 8y cubed dy dx to the left hand side, and the first term will be moved to right hand side, okay? Then this guy is 6y x squared plus y squared square dy dx and minus 8y cubed, this guy came from left hand side, right hand side, okay, is equal to 12x and minus, this guy came from left hand side, x squared plus y squared square. Almost there, okay? Then let me move to here, okay? We just split like this way, okay? And on your left hand side, let me pull out dy dx from these two terms, okay? Then with the big parentheses, dy over dx. Then first one, 6y x squared plus y squared square and minus 8y cubed is equal to 12x minus 6x times square, square, and square. Okay? Then, like definitely, we're going to divide by whole this thing on both sides. Okay? Then, your dy dx is equal to big fraction. Okay? And 12x minus 6x times square, square, and square over 6y x square, square, and too many square, and but that's it, okay? 8y cubed, okay? This is your dy over dx. What about this problem, okay? It's implicit differentiation, okay? But again, implicit differentiation is same with the chain, okay? So we can take it as like chain, okay? Here we go. So let me take the derivative of given function, okay? Because the question is to find g prime of 3, right? Then look at the first one. Gx to the gx squared. So square is outside function, and gx is your inside function. I'm talking about chain, okay? So, but like it is also implicit differentiation, okay? So it is 2 times power to the 1. It is just invisible, okay? Then keep that in mind. There is inside function. Once you write the inside function, you have to multiply inside function prime. Don't forget this part, okay? And the second term, 12x prime is just simply 12. That's it, okay? Now it is time to move to the right-hand side, okay? But for the right-hand side, you have to be careful about that, okay? As I told you, x squared times g. It is product form. There is no shortcut, but you have to do the product rule no matter what, okay? So here we go. So let's say x squared is first function. Let me use this color. And gx is your second function. Let me use pink color, okay? Then by the product rule, okay? X squared prime is just 2x, right? Times second function, okay? And plus first function times second function prime. That's it, okay? So now we have to solve for g prime of x, okay? So how can I do it? Just like moving. This term, x squared times g prime x will move to the right-hand side, and 12 to the right-hand side, okay? From right-hand side to the left-hand side, and this one to the right-hand side, okay? So, there we go. Two g of x times g prime x minus this guy came from right-hand side, okay? Then on the right-hand side, 2x g of x and minus 12, okay? Almost there, okay? Then put out your common factor. I'm talking about g prime x, okay? It is 2g of x minus x squared equal to 2x g of x minus 12, okay? Just divide by whole thing, okay? Then g prime x is equal to 2x g of x minus 12 over 2 g of x minus x squared. Is it clear? Then now, just simply plug in 3. Then g prime of 3 is equal to 2 times 3 g of 3 minus 12 over 2 g of 3 minus 3 squared, okay? In the problem, g of 3 is given, right? Which is 4. Then 6 times 4 minus 12 over 2 times 4 minus 9. That is equal to 12 over minus 1. So your final answer is minus 12. That's it.